makahahadlang, walang maiiwan. Sama-samang lilipad, kamtin ang pangarap. Sa hamong kinakaharap, patuloy na aangat. Edukasyon para sa lahat, sulong edukanidad. Ito ang Masinlok School on the Air at mapakikinggan sa Serbisyong Putog Radio, DWSP 101.5 News FM.
Good day, Masinlok! Good day to our active learners from grade 8. Welcome to another day of discovering new things as we explore the world of science. This is your own air teacher for today, Teacher Edwin Ilani de la Cruz from Bamban National High School, always at the service of the Filipino learners. Join me in another episode of Learning Science as we explore the world of atoms. Since we will investigate and study atom, I want you to make yourself ready and remember the following. A-T-O-M. A. Always wear a smile and never frown as we explore new things about this topic. B. Try to look for a comfortable place where you can study and properly listen to our broadcast. O. Observant and a good listener are important attitudes in science. Make yourself have them both. M. Make sure that you have your pen, notebook, periodic table, and quarter 3 module in science titled Atoms Inside Out. Are you ready? Let's start! At the end of the module, you are expected to 1. Determine the number of protons, neutrons, and electrons in a particular atom. 2. Compute for the atomic number and mass number of a given element. 3. Describe the different models of an atom. And 4. Make an interference. An object may carry positive charge and negative charge. In our previous topic, we identified the different phases of matter and learned different processes by which matter may transform from one form to another. Can you identify those processes? Very good. These are melting, freezing, evaporation, condensation, sublimation, and deposition. Now, let us measure if you can still remember these processes. Open your module on page 4 and look for the activity What's In. In this activity, we will complete the table by identifying the processes involved. Let us check your answer. Number 1. The answer is liquefaction. Number 2. Liquid. Number 3. Vaporization. Number 4. Condensation. Number 5. Sublimation. And number 6. Gas. Now, you are ready to learn new knowledge and understanding about chemistry. Matter is made up of atoms that are too small to see with the unaided eye or even with the use of the ordinary light microscope. We all know that atom is basic building block of all matter in the universe. Every solid, liquid, gas, and even plasma is composed of neutral or ionized atoms. These are extremely small, around 100 picometers across. When the ancient Greek philosophers conceived the idea of an atom, they thought that atom is indivisible, that it has no parts. The Greeks were the first to propose physical explanation for this material. They believed that all matter is made up of what is called the primal matter. The idea that matter is made up of ultimate particles was advanced as early as the 5th century BC. Democritus pondered a piece of gold and reasoned out that if a piece of matter like gold is divided into smaller pieces, one would finally arrive a tiny particle of gold that could not be further divided, but still retain the properties of gold. He called this ultimate particle of matter, which cannot be divided, as atom. He explained familiar events such as the drying of clothes, spread of odor, and growth of crystals in terms of his atomic concept. He imagined atoms scattering or collecting as these events happen. To explain the softness and high density of lead, he pictured that lead atoms as closely packed like marbles in a box, moving easily over one another. He called this the theory of the universe, by which all matter consists of atoms, which are bits of matter too small to be seen. There is an empty space between atoms. Atoms are completely solid. Atoms have no internal structure, and each atom is different in size, weight, and shape. But during the time of Aristotle and Plato, these two persons did not accept the atomic idea of Democritus. They were so against it and demanded that atoms be shown to them. They thought that atoms challenged God, because if atoms can explain everything, then there is no need to believe in God. Plato proposed a mathematical construction of the elements, the earth, air, fire, and water. Each of these elements is said to consist of particles or primary bodies, while Aristotle supported Plato's idea. He called the four elements as empedocles and included the fifth one, the ether, which accounts for the material heavenly objects, which he considered unchanging and eternal. For many centuries, Democritus' idea of atoms was either ignored or rejected. But in the year 1800s, the idea about atom has become clearer to the scientific community. John Dalton, an English scientist, postulated that atom was extremely small and invisible, much how like Democritus had described it. He also explains that matter is composed of atoms of differing weights and combined in simple ratios by weight. From that, he developed Dalton's atomic theory, which states the following: all matter consists of tiny particles called atoms. 2. Atoms are indestructible and unchangeable. 3. Elements are characterized by the weight of their atoms. And the last one, When elements react, it is their atoms that have combined to form new compounds. As we observe in his model, matter is purely made up of an atom, and this can combine to another atom to form a new compound of matter. The next person who gave another brilliant contribution on the development of an atom was Sir Joseph John Thompson. In the 19th century, J.G. Thompson was able to discover that atoms have negatively charged particles, which he called the electrons. He used a cathode ray tube, which led him to propose new model for an atom, which he called the plum pudding model. He also proposed that the negatively charged electrons were embedded in a kind of cloud or soap of positive charge. These are the key points to Thomson's atomic model. Because of its design, this model is known as the plum pudding model. Each atom is a sphere filled with positively charged fluid. This resembles the sticky jam part of a pudding. Corpuscles are the negatively charged particles suspended in this fluid. This resembles the plums in the pudding. He did not predict the movement of the electrons. Another group of scientists, headed by Ernest Rutherford, tested Thomson's model by bombarding a very thin sheet of gold foil with positively charged alpha particles. Ernest Rutherford was not convinced about the model of the atom proposed by Sir J.J. Thompson. He thus set up his own famous gold foil experiment. And in this, he fired alpha particles at the gold foil. He also measured the deflection as the particles came out the other side. Most of the particles did not deflect at all. Every now and then, a particle would deflect all the way back. He said there must be a positive center at the foil, and he called the center as the nucleus. The nucleus of the atom is the dense mass of positively charged particles. The electrons orbit around the nucleus. But a problem raised was, why are the negatively charged particles are not attractive by the positively charged nucleus? Rutherford stated that the atom was like a mini solar system, in that the electrons orbited around the nucleus in a wide orbit. That is why it is known as the planetary model. The next person who contributed for the development of an atom was Niels Bohr. Niels Bohr agreed with the planetary model of the atom, but he also knew that it had a few flaws. Using his knowledge of energy in quantum physics, he was able to perfect Rutherford's model. He was able to answer why the electrons did not collapse into the nucleus. He hypothesized that the electrons are located in specific orbits or energy level outside the nucleus. He introduced the concept of quantum levels, which are allowed orbits for an electron. And from that, he theorized the following. Electrons orbit the nucleus in orbits that have a specific size and energy. The energy of the orbit is related to its size. The lowest energy is found in the smallest orbit. Electrons reside in orbits They move between each shell when gaining and losing energy. When gaining energy, electrons move to closer orbit from the nucleus. And Erwin Schrödinger. He was a revolutionary physicist who used Heisenberg's uncertainty principle to come up with the atomic model that we still use today. He discovered that electrons don't move around the nucleus in orbits. Electrons exist in specific energy levels as a cloud. The electron cloud is the region of negative charges which surrounds the nucleus. And the region with a high probability of containing electrons are the orbitals. Scientific discoveries through the years led to the identification of the fundamental particles of the atom. Particles which make up the atoms are called subatomic particles. The atoms composed of 3 subatomic particles, such as the protons, electrons, and neutrons. The protons are the positively charged fundamental particles found inside the nucleus of an atom. Atoms of a particular element have the same number of protons. In fact, the number of protons is unique to each element. Neutrons. Neutrons are another subatomic particles that can be found inside the nucleus of an atom. However, unlike protons and electrons, neutrons have no electrical charge. Therefore, neutrons are said to be neutrally charged. Atoms of a given element do not always contain the same number of neutrons. Atoms of an element that have a different number of neutrons in the nucleus are called isotopes. Electrons are the negatively charged particles that orbit around the nucleus. It is the electrons that participates actively in chemical bonding. The sharing or exchange of electrons between atoms forms chemical bonds, which is how new molecules and compounds are formed. At ground state, the atom is generally neutral in charge. This means that the number of protons and number of electrons of an atom are equal. So far, you have learned about the subatomic particles, the protons, electrons, and neutrons, and how they arrange in the currently accepted model of an atom. Atomic number and atomic mass plays also an important role in order to determine the subatomic particle of a certain atom. What then are the atomic number and atomic mass? Please get your periodic table for you to easily identify them. An atomic number indicates the number of protons in the nucleus of an atom. The number of protons from elements to another element is unique. Any change in the number of protons results to another element. But remember, the number of protons and the number of electrons in the element is always the same. Atomic mass. Because atoms are too small, their masses cannot be measured in grams or milligrams. To compute the atomic mass of an atom, find the sum of the number of protons and neutrons in the nucleus. Atomic mass gives us the relative mass of the individual element. Now, using your periodic table, let us determine the number of protons, electrons, and neutrons of a certain atom of an element. Let us have magnesium. The atomic mass of magnesium is 24, while its atomic number is 12. Can you guess the number of protons, neutrons, and electrons of the magnesium atom? Very good. The number of electrons and protons can be determined by finding the atomic number. Since the atomic number of magnesium is 12, then we can conclude that there are also 12 protons inside the nucleus and 12 electrons orbiting around the same nucleus. How about the neutrons? Find the difference between the atomic mass and the atomic number of magnesium. So 24 minus 12, the answer is 12. From that, we can say that the number of neutrons of magnesium atom is 12. Now, let us measure your understanding regarding this topic. Let us answer what's more, activity 1. In this activity, you must study the illustration and answer the questions under each frame. You have to identify the subatomic particle being described. Number 1. Part of an atom with a positive charge. Correct. The answer is proton. Number 2. The part of an atom with a negative charge. Correct. The answer is electron. And number 3, the part of an atom with neutral or no charge. Correct. The answer is neutron. Now let's move on to activity 2, charge me. In this activity, you have to study and analyze the given situation based on the concept of the different electric charge. Answer the given questions by choosing from the words enclosed in parentheses. Rubbing the plastic strips with the whole cloth causes the strip to become A. Negatively charged, or B. Positively charged. Number 2. Consider the charge on the cloth after the rubbing action. A. Negative charge. B. Positively charged. Number 3. When the plastic strip is hung over the wooden rod, the two halves of the strip move A. Equally, B. Not equally from each other. Now, let us check your answer. For number 1, the answer is negatively charged. Number 2, positively charged. And number 3, the answer is equally. Now, let us have the last activity. Activity 3, count my charge. Count the different electrically charges found inside of an atom A and atom B. Write your answers on your notebook on a separate sheet of paper. Number 1. How many positive charges are there in atom A and atom B? Number 2. How many negative charges are there in atom A and atom B? And number 3, how many neutral or no charges are there in atom A and atom B? Let us check your answer. For number 1, the answer is 1 and 8. Number 2, the answer is another 1 and 8. And number 3, 0 and 9. How's your score, dear learners? Always remember that you are doing great in everything that you do. Always bear in mind that there are better things than getting high scores. What important is you learn from your mistakes and become a better learner at the end. Your science teacher will wait for your output. Our dear parents, guardians, and learning facilitators, your guidance can make a difference on how well your children can accomplish the learning task. Kindly provide them assistance. Thank you for your support to possibly accomplish the task and for gradually helping them to become independent learners. If you have questions, just message your science teacher for they can help you to be enlightened in the parts that you have doubts and difficulties. You can do it, learners. Let us help each other to make this new normal education successful. Once again, this is your own air teacher, Ma'am Edlin Ilani de la Cruz of Bamban National High School. Thank you and have a good day.